Okay, so how do we add sensors to a Raspberry Pi? Well, first we need to talk a little bit about what sensors actually are. Sensors come in many different shapes and sizes, and they generally add the capability to measure an environmental factor of some type. So for instance, the simplest possible case is this device here. This is a light sensor. You can see there, you've got a little light sensitive resistor, which measures how much light is being received at that particular component there. So that resistor will change the voltage that is being passed through this sensor here, and the device that's controlling it, like this Raspberry Pi, can measure that voltage. Except actually a Raspberry Pi can't measure voltage on its own. It needs a special analog to digital converter device to be able to measure voltage. Similarly, we have a line finder there that has these two little photodiodes, I think. We've got a simple switch here which will tell you if there's voltage or not. There's a knob here which is a potentiometer, and as you change the position of the knob you have more voltage going through that potentiometer. Here's another example. This is an infrared light sensor. So instead of looking for visible light, this looks for infrared lights like you might see from a remote control, for instance. And here's a moisture sensor. So you place these two probes into soil, for instance, and you can measure the amount of moisture by the amount of electricity that passes between these two probes. So those are some analog sensors that measure voltages. Here we've got a couple of other sensors. So this is a 3-axis gyroscope. This is a 3-axis gyroscope, and you can see it's got a chip here. That's the gyroscope actually. And this is a digital sensor, so it's measuring a lot of things at the same time. It's not necessarily just making a voltage with a resistor, it's doing a bit more. Similarly, here we have an accelerometer here. You see there's another one of these chips in the middle there, surrounded by other smaller chips. That inside that chip is the mechanism to measure the acceleration in the X, Y, and Z dimensions, so 3 dimensions simultaneously. So we're not going to send out 3 voltages, we actually use a digital signal to communicate those numbers. And over here we've got a distance sensor. This is an ultrasonic distance sensor. This sends out a pulse and waits to hear the pulse back. So this is kind of a bit different. It is sending digital pulses, clicks, and then receiving those digital pulses back by using its microphone inside there. And by comparing when it's sent and when it received those pulses digitally, by using numbers, it can calculate the distance to any surface that it's pointed at. And finally, here's a digital knob. This is an encoder, and it makes clicks every time you turn it around, and you can keep on turning it around for a long way. So this is a device that can measure a number of clicks in a particular direction, and unlike the analog knob, it continues infinitely around. So there's a number of different sensors. We have some that are digital, that communicate through signals, and some that are analog. These ones can communicate through voltage. So digital signals over here, numbers and data, and voltages over here, continuous voltages that need to be measured. Okay, so what is a Raspberry Pi? Well, a Raspberry Pi is a single board computer, which means it has a processor, RAM, inputs and outputs, and storage in the form of an SD card. It's all on the one printed circuit board, so unlike your typical desktop PC or a laptop computer where there's lots of different parts connected together, the whole computer is here. It's all in one board. And because of that, it's quite a lot cheaper. The price is a fraction of the price of a normal laptop these days. It also uses less power. It does still come in a variety of different shapes and sizes, but they're all small like this one. So here's an older Raspberry Pi. This is from 2011. And you can see it's fairly similar except for this big jack up the top here, and then we've got a few less pins, and some things have been moved around into different places, but it looks pretty similar. We've got this board here as well. This is very similar to the other one I showed you, but it's shorter and it has less ports. And then this one's really cute. This is a Raspberry Pi 0W, which has a very small number of ports, and we've swapped a full-size HDMI for a mini HDMI there, and our USB ports are micro USB. But we've still got our 40 pins up the top there. This one is very, very cheap and very useful. Still has a lot of power for running a lot of different things. So what's on an actual Raspberry Pi? Let's take a bit of a closer look at the Raspberry Pi. So I'm going to zoom in a bit. To start with, we've got this power in jack. A Raspberry Pi is powered by a USB cable. Now that USB cable might be connected up to your computer, or it could be connected to a power adapter, connected into normal AC, or even a power bank, one of those little mobile phone charging power banks that are portable. That makes the Raspberry Pi not need to be connected to any mains power source. So a Raspberry Pi is powered by USB, and this USB port specifically isn't used for communication at all. If we go around a bit further, we've got a little display port there. That's a ribbon cable connector used for connecting smallish displays usually, sometimes touch screens of say 6 or 8 inches. Up the top here we've got 40 bare metal pins. These are used for expanding the capabilities of the Raspberry Pi, and they're quite useful for attaching all manner of sensors and displays. Over on the right hand side here we've got 4 USB ports. We've got 2 stacks of 2 USB ports there, you can see. And below that we've got an Ethernet port, so that's for traditional networking. We've also got a mini jack for a headphone or for a microphone, so you can use this with one of the headset type microphones where you have both the headphones and the microphones running at the same time. Next to that you'll see we have another ribbon cable connector. These ribbon cable connectors open up like so, and then the ribbon goes in and then you click it closed. You can see that's for a camera. So Raspberry Pi makes some very interesting cameras that connect specifically to the Raspberry Pi. And then here we have the HDMI port. This is a traditional HDMI port, and that's a much easier way to connect a display to a Raspberry Pi. And finally, actually on the back of the Raspberry Pi, we have the micro SD slot. So here you can slot in a micro SD card, and on that card you can have your operating system and all your files. So that's a quick introduction to the Raspberry Pi. There's a wide range of them available. This is a Raspberry Pi 3, and they've released the Raspberry Pi 4, which is, again, very similar, but it has more power. It has a couple of HDMI ports instead of only one, and it's around about the same price, so they haven't changed much of the formula. So we'll be talking more about how to connect interesting things like sensors and how to make the Raspberry Pi play sound shortly. Okay, if you take a close look at these devices here, these are devices made by Seed Studio, and they have a kind of a standard connector, but the connectors connect with different formats. And if you take a close look here, we're going to zoom in, you can see that there are 4 wires and they have names. So you can see ground, VCC. VCC means voltage, 5 volts specifically. NC means no connection, and then SIG is the final wire. And that's where the voltage that represents the amount of light is passed. So the sensor needs some power, so we've got ground and voltage, and then we have one cable for the voltage that measures the light. That's an analog sensor. Comparatively speaking, we've got the digital sensor here. And if we look at this, you can see ground, VCC, SDA, and SCL. So those are the 4 cables that make up the I2C connection that is used in a lot of places. SDA means the data line, and SCL means the clock line. and ground and VCC are the normal ones. We need some power to run everything, of course, so we need ground and VCC, but in this case, we're going to send all of the numbers digitally down this data line, and this data line is going to be controlled by this clock. So that means we can use a simple sensor like this to measure lots and lots of values simultaneously and then send them in order down a data line. So this is a common way of having a digital chip on a sensor board and then passing lots of data to a computer at the same time. And this is quite easy to interface into a Raspberry Pi without any add-on boards at all being necessary. To use any of the analog sensors, you'll need an Arduino connected by USB or some other type of add-on board that allows you to connect to an analog to digital converter to your Raspberry Pi. Okay, for some sensors, however, the Raspberry Pi can't connect with I2C because I2C doesn't give the required connections necessarily. So a good example of that is the camera board here. So this is a Raspberry Pi camera, and it has this ribbon cable with a number of contacts on the end here, as you can see. And to connect that, you plug it into the Raspberry Pi here and close that down. It's a standard connector called a CSI connector for cameras for the Raspberry Pi, and it provides enough connections that the amount of data that's going to be necessary to pass down that connection can indeed be connected. So cameras are a bit different, and they have their own special connector. Okay, so if you're using the Raspberry Pi to make sound of some type, to play samples or to synthesize sound, you'll probably want to work out how to get sound out of the device. Now there's three ways I want to talk about that each have benefits and drawbacks. And the first way is to use the mini jack here. We've got a mini jack connector, which is a pretty straightforward way to connect some headphones, but you can also use it with one of these mobile phone speakers. So you can plug that directly in with a mini jack cable and you'll get relatively good sound for not much effort. This is probably the easiest way to get a speaker attached to your Raspberry Pi without doing too much work, and it has the benefit that it's relatively loud because these speakers are pretty powerful for their given size, but you do have to recharge the speaker as well as organizing power for the Raspberry Pi separately. So there are some drawbacks with that. But overall, this is a pretty straightforward way of getting some sound out of your Raspberry Pi and keeping it portable. The second way that is pretty capable is using HDMI audio. So you can connect an HDMI cable to your audio system, and that can go into your hi-fi or to your TV, or indeed to some larger systems that take HDMI digital audio out of the Raspberry Pi. And this is also not particularly difficult to set up as well, because Raspberry Pi provides the Raspberry Pi config utility to select HDMI audio. Now, one trick is that sometimes you'll be trying to use the mini jack audio and the Raspberry Pi will be set to send audio out of the HDMI port, but it doesn't tell you that. It just does it, and you think there's no sound coming out, but it's actually coming out the wrong place. So those are two simple ways to get audio out of the Raspberry Pi. A slightly more complex approach to getting this working is to use an add-on board. Now there's a variety of add-on boards available with different capabilities. This one has an amplifier on board, and it allows us to power it with various forms of power, and you can plug in a speaker directly to the add-on board, and you get probably louder sound because the amplifier is bigger and can use higher power, and you can customize your audio solution with an add-on board like this. So this means also that you only need one power source for the whole system. So you don't need two separate batteries in your system, and you need to recharge both of them. So this is a great solution if you can organize it. There's a variety of options available. Hi-Fi Berry makes some very good add-on boards with different amplifier levels available to help you add speakers to your Raspberry Pi. Okay, so those are three different ways of organizing audio on your Raspberry Pi. The first two, the mini jack and the HDMI, will work with the normal base operating system image, But if you want to use an add-on board, if you use this particular one or the Hi-Fi Berry one, we provide an image at happybrackets.net that allows you to set that up without doing any extra work. But other add-on boards may require more or less configuration to function. Okay, so the discerning amongst you might be asking, isn't a Raspberry Pi just like an Arduino? I've had Arduinos for years. The first one came out in 2004 or thereabouts. And they're a well-established device for adding physical interaction and for gaining sensor input from a computer. So what's the difference? Aren't they just the same? They're actually quite different in usage, and they are not necessarily one's better than the other. They're just a completely different concept. So if you look at the Arduino, you'll see it has a USB input, so you can take a cable from a computer and plug it into the Arduino, but it has no output, so you can't plug a mouse into an Arduino. You can only plug the Arduino into a computer. However, on the Raspberry Pi, you can see you've got USB ports there, so you could plug a mouse into a Raspberry Pi, and you've also got an Ethernet port and an HDMI port, so you can use a screen with a Raspberry Pi. This Arduino has this big Atmel chip in the middle, and that's the core of the Arduino. Inside there is some rewritable memory so that you can write a program onto the chip, and every time the chip loads up or is powered, it will run that one single program, and it will run it in a kind of single-minded fashion, which is really useful. So unlike the Raspberry Pi, which is a full single board computer, you can check your email, you can run YouTube, you can also run programs that read sensors all at the same time. There's a lot of confusing code happening in the background. The Arduino is not like that. The Arduino only runs one program at a time, and those programs are relatively simple and use a lot less memory. So on an Arduino, there'll be 32 kilobytes of memory in most circumstances. But on the Raspberry Pi, you've got gigabytes of memory. And you also have a storage disk. So you've got your SanDisk SD card, for instance, that might have 16 or 32 gigabytes of space to store huge files or to save files. Now you can add all those things to an Arduino, but that's more complexity, and you need to write programs that allow you to manage all of that alongside it. So the Arduino is simpler, more focused. It has a very specific goal, but it only will run one program at a time, and it can't manage things like cameras or USB devices in the same way that a computer would. It is always possible to do these things with an Arduino, but it is complex. But it's very good at what it does. Raspberry Pi is a more complex device. It has a huge array of capabilities, and you can write programs in Python, in C, in Java, in any language you like, because it's a full computer with an operating system rather than just a simple chip that is reprogrammable. So there's a big difference between the two, and they excel at different tasks. So I wanted to talk a little bit more about the pins at the top of the Raspberry Pi here. These are the bare metal pins that connect to the computer and allow you to add on extra sensors and outputs and different capabilities to a Raspberry Pi. I'll show you a couple of these little add-on boards. So here is what they call a sense hat. This has a number of different sensors that are connected through this 40-pin header. You can see we've got an LED matrix here, which can do red, green, blue. And then here you've got an accelerometer, a gyroscope, and a magnetometer, which is a compass. You've got a humidity sensor, you've got a pressure sensor, and you've got a little joystick here as well. There's also a temperature sensor in there somewhere. So this has got a number of sensing capabilities and a couple of output capabilities as well. This board here is an audio board. We've got a number of connections for connecting line outs and line ins. There are actually a couple of microphones up there at the top left and top right. You might be able to see the D mic label there. And then we've got some digital connectors on the left-hand side there. This one is a similar type of audio board, but this is designed to be used with the Raspberry Pi Zero, so it's a bit smaller. It has a 12-volt input and an amplifier on board. And on the left here, we've got connections for speaker output, so you can power a speaker with this board, which is really great. Hidden in here as well is accelerometer and gyroscope, which is really useful for getting data that can control sound. And finally, here's a big board. This is a Grove Pi, which is a flexible way of connecting a variety of sensors. It's basically like a way of connecting sensors through an Arduino straight into the Raspberry Pi in one board, which is very nice. So you've got a range of different ports there. They all look the same, but they are actually a bit different, each one of them. And it connects through just a few of these pins here, which connect onto the end of the 40-pin header. So there's a number of different boards. How do you connect them? Well, any of these boards, you just basically line up the pins, which can sometimes be difficult if they're a little bit bent, and push them down. Some boards will come with standoffs that you can use here to screw in support between the two boards and make sure it doesn't move, but it'll still work without those. So there you go. There's a bit of an introduction to some of the add-on boards that you can use with Raspberry Pis.